welcome you all for the design thinking based discussion on smart agriculture systems using electromagnetic waves. And with the rapid development in the agriculture sector, we need an efficient, robust and also data driven farming methods for better management of agriculture sector. And with waves such as radio waves, microwaves and infrared waves contribute to more efficient agriculture monitoring systems. So in this case study discussion, we are discussing how a design thinking based approach used to design a better health monitoring system for agriculture crops, and this will be providing farmers for better pest control and also the agriculture monitoring, crop monitoring, everything. So let us start.
Problem definition. Farmers struggle with insufficient resource management, and second one is the weather patterns are unpredictable, increasingly unpredictable, so the crops are damaged. And third one is the weather cultivation. In some areas the land will be fertile, in some areas the land will be unfertile, so the crops will be well grown in fertile areas and ungrown in the unfertile areas. And last one is the invention, the microwaves based system we are introducing in the agriculture, which will be useful for the agriculture. And objectives are, we are introducing agriculture system using microwave based systems like IFR and IR and microwaves. Example, we are using it for sensors, sensing the pressure, moisturizer and temperature of the soil for the growing the plants. And we are using sensors. Sensor is the main thing in the agriculture in microwaves, because every part of the soil is important for the plant to grow. If the water moisture content is it should be maintained equal or an average pH, or if the pH is high, the plant will won't grow, or the pH is below it, average, the plants will be get rotten or spoiled. So implementing the microwave based system in agriculture is most important, and it will be useful for the farmers and the agriculture.
I am going to speak about the empathy part of the video. The main aspect of the farmers and agricultural experts are to the farmers are mainly want to know about the soil condition of the soil, the weather conditions. So they want to use the gaining insights of the farmers and agricultural experts are the farmers want to know about the soil moisture, temperature and the weather condition. So they are how they can irrigate the plants at regular intervals of time. They want to see the irrigation time, so the plants want to give a life to that. And the basic tools used for agriculture are not even accurate. They are not used for precision agriculture. Most of the tools used like seed drill, bows and the ploughing instruments like tractor are mostly used by the farmers. And for the perfect agriculture, they are using many other tools. The farmers mostly doesn't have the time to check the crops and plants, so they want to check the plant, so they have to allocate a separate timing for checking the plants. Most of the pesticide using and wastage of water has become a key role in agriculture.
Okay. And the next is define part. In define phase, key problems are data collection, need for monitoring the crops daily and crops health. And next one is efficiency, need to reduce the resources such as water and fertilizer by better decision making. Efficiency, making the system affordable to farmers and easily usable to the farmers. And the opportunities are remote sensing, using electromagnetic waves and measuring the soil's moisturizer and temperature.
Okay, the third stage is ideate, and in ideate phase, we are going to brainstorm multiple solutions which leverages the agriculture practices using EM waves. Here, I would suggest 4 different ideas. The first idea is RFID soil sensors. Using RFID technology, we are going to create a smart soil sensor which will give you the parameters related to soil. For example, the nutritious content in the soil, moisture content of the soil, and temperature of the soil. Secondly, we are going to use infrared imaging for pesticidal infections. So when the soil is okay, we need to focus on the plant health. In plant health, major deficiency is these pests. For monitoring that, we are going to use an infrared camera which will detect the temperature of the plant, and using that we can see the pesticidal activities and diseases related to that. And thirdly, we are going to use microwave irrigation system. When the soil is fine and the plant is fine, thirdly we are going to water the plants, right? For that we are using this microwave irrigation system. Using microwave sensors, we can detect the temperature of the surroundings and moisture content of the soil, which will intimate the microwave sensor to water the plants automatically. And finally, we are going to use Finally, we are going to use wireless data transmission, in which the remaining sensors will have certain data, right? That data will be transmitted wirelessly, and we can set the farm, which will be useful for the farmer, where using remote apps, the farmer can monitor the other conditions of the.
So we are going to see the prototypes of the problem statement, and there are 4 feasible ideas of this problem statement, and the prototype is about, like, the first one is soil moisture moisture controlling system, and is monitors how the soil monitors the moistures of the soil, and it directs and notify to the farmer that the irrigation is needed. And the second one is about infrared camera based detection system. Is the infrared camera is placed on the soil and detect the soil moisture levels, and it uses to it has the potential to face the problems of the plants. And his fourth one is third one is a microwave irrigation controller, and it is used to is based on a sensor. It's a microwave sensor. It used to detect the moisture levels of the soil at various depths, and in the when the irrigation is needed accordingly. And fourth one is a central data hub. It is used to stores the data information from all input sensors, so that we can easily share the real insights of the crop health and pest protection and soil condition.
Now let's talk about the testing phase. In testing phase, we will give the prototype to the farmers, and we have to tell them to use it, and they will give the suggestion like how we have to improve the prototype. First, soil moisture systems. In soil moisture systems, the farmers have appreciated us in the real-time updates, and also tell us to improve the accuracy of the moisture level of the conditions in different types of soils, like how it is affecting or acting on the crops at different types of soil. Next is infrared pest detection. In infrared pest detection, it have detected successfully the temperature, and we also need some further needed calibration to detect the specific pest, like how it is acting on other types of soils. Next is microwave irrigation. It has showed the reduction of the water, like and we also need some facilities to check the changes in weather to avoid over irrigation.
Hypothesis impact and outcomes and the water consumptions. The microwave based infrared systems, it's used to reduce the water usage. The farmer reporting 30 to 40% of water consumptions, increasing crop aids. Using the infrared technology, the pesticides infrared is to reduce the usage of pesticides and is an time efficiencies. Using the RFID soil moisture sensors and automated technologies, it's very useful to farmers. The farmer to do all their other aspects of an farming and all other things, and this sustainability. So it is useful to help minimize of wastage and consider the more sustainable to practice and less environmental impacts.
Thank you, dear students. You have started well with the design thinking 5 phases. Starting from the problem statement, you have gone through empathy, define, ideate, and problem solutions, prototype, and evaluate also. And this is a good discussion how the design thinking is used to develop a smart agricultural management system. Thank you so much.
Thank you.